Hi class, in this lecture I would like to talk about modify simplex method. Modify simplex algorithm includes two-phase method in the beginning of the simplex algorithm. Once there are some constraints which are not less or equal to sign. And also, to deal with restricted variables, when there is a variable which can have a minus or plus sign, how can we deal with that and apply simplex algorithm? So for the modify simplex algorithm, there are two rules. Rule 0 is to express the given constraint as equality. Because we have three types of constraint. For the constraint with less than or equal sign, we insert a select variable with the coefficient of +1. And if the constraint sign is greater than or equal to, we insert surplus variable with a coefficient of -1, but in order to maintain the number of bases, we need to insert an artificial variable with a coefficient with +1. For the constraint with equality, we only need to insert artificial variable with coefficient +1. Rule 1a, form an artificial objective function as a negative sum of artificial variable. Try to obtain the initial basic solution by setting each select variable and each artificial variable equal to the corresponding constants to the right-hand side of the constraint. Rule 1b, if no feasible solution, once an artificial variable is positive in optimal solution for artificial objective function. So we summarize all of these steps, including the simplex algorithm. Then we will find the flowchart is as this. Okay, so we start to insert select surplus artificial variable, then generate initial solution and apply simplex algorithm for artificial objective function. So if all artificial variables are 0, then we try to drop all the non-basic artificial variable and function and try to apply the normal simplex algorithm to actual objective function and try to find the final optimal solution. If all the artificial variables are not 0, then we can stop because no feasible solution found. And then now we give an example to know how to deal with the unrestricted variable. The example is maxima z equals to 3 times x1 plus 2x2 plus x3. We have two constraints. The first one is x1 plus 2x2 plus 4x3 less than or equal to 24. And the second constraint is 10 times x1 plus 4 times x2 minus 5 times x3 less or equal than 100. x1 and x3 are positive variables, but x2 is unrestricted variables. So we cannot direct apply the simplex and solve it because x2 might be negative variable. So what can we do? We try to create a new variable instead of use x2. Okay, the strategy here is we try to use w1 and w2, and we use x2 equals to w1 minus w2. So if x2 is negative, then w1 equals to 0, and w2 is a positive number. And if x2 is positive, then w1 is a positive number, w2 is 0. Okay, so we put the x2 by w1 minus w2. Okay, then we can use the for variable into the Simplex tableau. Okay, so now we change the objective become 3 times x1 plus 2 w1 minus 2 w2 plus x3, and the two constraints are x1 plus 2 w1 minus 2 w2 plus 4 x3 less or equal to 24, and we add s1 as a select variable into the constraint 1, and the second constraint will become 10 times x1 plus 4 times w1 minus 4 times w2 minus 5 times x3 less than or equal to 100, and we added x2 as a surplus variable into second constraint. Okay, so we got the initial tableau like this. Okay, and then we use the normal simplex method. Okay, and because the -3 is the least value, and replacement quantity here is 10, here is 24, so 10 would be the pivot cell. And then we got the second tableau. Okay, and now because here still have minus number, so we can continue our tableau. Okay, so according to this one, we choose w1 as a pivot column, and we will find this number, this cell based on the replacement quantity is smaller than the 25, so this one is the cell. Okay, and then finally we get the tableau like this. Then the x1 is 13 divided by 2, and the x3 is 0. How about x2? Okay, so we can see w1 is 35 divided by 4, and because w2 with the coefficient -1, then w2 is 0, so x2 is 35 divided by 4 minus 0, get this number. Okay, so in this lecture, I summarize how to use two-step method into Simplex algorithm, and also once we have some variable with unrestricted, which means it might be positive or negative. Then we use two positive variables instead of the original variable, and we construct the simplex table, and once we get the final solution, we can use this new two variable put together and back to the original variable, which is unrestricted. Okay, that's these lectures. See you. Bye bye.